When we are solving a radical equation, you want to first make sure that the radical is by itself. So you'll notice in this particular equation, this is my radical here, and it is totally by itself. So once it is, the way you get it to cancel is you look at what we call the root, also known as the index of the radical. And whatever root you have, you're going to raise both sides to that same power. So since we have a cube root, we're going to raise both sides to the power of 3. What happens is that power will cancel out that root. So on the left side, you're just going to get the expression that was underneath the radical. And then on the right-hand side, I go ahead and simplify that. 3 to the power of 3 would give me 27. 3 times 3 is 9. 9 times 3 is 27. At this point, you will either have some type of a linear or quadratic equation that you then need to solve. In this case, I have a quadratic equation. In order to solve quadratic equations, I must first set them equal to 0. So I will subtract 27 on both sides. And that will leave me with a 5z squared plus 6z minus 27 is equal to 0. Now, with quadratics, always try to factor first. And then if for some reason the quadratic does not factor, then you can use the quadratic formula to solve it. In this case, I will first look at my leading term, which is a 5z squared. And I know when I break that apart that I would have to multiply a 5z times a 1z in order to produce a 5z squared. Now next, I actually look at my constant. It is a negative 27. And what I want to try to do is use factors of negative 27 so that when they combine with my other factors of the 5z and the 1z, I can produce a positive 6z in the middle. It does take some trial and error, and the more you factor, the better you will get at it. So I usually try to start somewhat in the middle. Basically, I don't want to start with 1 times 27, so I'm going to start with 9 and 3. And I would probably try to put a 9 here and a 3 here so that I can see what kind of middle terms that will produce. So that would give me a 9z as well as a 15z. And remember, my goal is I'm trying to produce a positive 6. So if the 15z were positive and the 9z were negative, I know that a 15z minus a 9z would produce the 6z that I need in the middle. I also know that my negative 9 times my positive 3 gives me the negative 27 that I needed for my constant. So those are my two factors. Once you have a quadratic factored, you set each particular factor equal to 0. So the only way a product can be 0 is if one or both of the factors are 0. And then solve. If 5z minus 9 is 0, I can add 9 to both sides. I'm going to get 5z is equal to 9. Divide both sides by 5, and I have one possible answer of 9/5. And then if z plus 3 is equal to 0, I can subtract 3 on both sides, and that would give me another potential answer of z is equal to negative 3. Okay, so unfortunately, when you're solving radical equations, you do have to check your answers. You cannot just assume that they are both acceptable. So I went to Desmos, and on Desmos I plugged in each answer in for the z in this particular case. So notice on this first one I've put in the 9/5 in place of z. And when I hit enter, I want it to see, does it equal the 3 of my original equation? And in that case, it did. So I would say that answer checks out okay. And then I took my other potential answer of -3, and notice I plugged it in as well to the original equation. And when I hit enter, it also equaled 3. So in this case, both of my solutions I actually keep. I don't throw either one out. They're both solutions to that particular radical function. Okay, so on this next problem, don't let it confuse you if they write it in what we call a rational form. Even when they write it in a rational form, there still is a root. And so the root is always the number that is on bottom. Now, we talked earlier that you want to get the radical by itself, so you can do one of two things. First of all, if you want, you could rewrite this as the cube root of x squared. Since there's a 3 on bottom, that means it's a cube root. And then it has minus the 25 over 36, and that is equal to 0. So we said earlier, you have to have the radical by itself before you can get rid of it. So in this particular case, we would need to add the 25 over 36 to both sides so that we can move it over. So at this point, we have the cube root of x squared, and that is equal to 25 over 36. Now, in order to cancel the cube root, we will raise both sides to the power of 3. So that cancels the cube root, and that leaves me with an x squared equals, I'm not going to cube these out just yet, and you'll see why in just a minute. So that's to the power of 3. And then when we ask ourselves, how do we get rid of a squared power? Well, the inverse of squaring something is to square root. So we would square root both sides, and anytime we square root both sides, we have to consider that there could be both a positive and a negative case. And so in this particular case, I'm going to go ahead and square root, and with my plus and minus, the square root of 25 would give me a 5 on top, the square root of 36 would give me a 6 on bottom, and then I can come back and cube each of those. And so when I cube positive 5 over 6, I'm going to get one possible answer of 125 divided by 216. And then when I cube the negative 5 over 6, I'll get negative 125 divided by the 216. So now when I would go to my calculator and check these particular answers, as you can see here, let me just kind of put it, I guess, right here in the middle. So I plugged it in over here. There's my positive 125 over 216, and notice when I plugged that in and carried out the rest, it equaled 0 like the original equation. And then notice when I plugged in the negative 125 over 216 and the rest of the equation, it also equaled 0. So once again, I have two particular answers that do exist.